Okay, so somehow you want to take this thing here and turn it into a function where you can apply Rolle's theorem. So, and Rolle's theorem is about zeros. So I'm going to do the following.
Rolle's theorem is just the value theorem, so it's saying it's equal to the secant. So the secant is
Kind of. So exactly what Zoe had on the board, like you want your new function to have the same derivative as the function inside that you want you're carrying and you care about. So you need that. So this was your show, which you had on your boards. There's the C, of course. You want that. I suggested to you that you replace your B with an X. So scratch work. Replace it like this. So we have f of x minus f of a is equal to f prime of c times x minus a. We don't have a function yet. This is what I'm trying to find. I'm trying to find this guy here, but I don't have that guy here. I don't know that the c exists, so I can't really write this. You could put f prime of c, but then if I have f prime of c in here already, I can't apply Rolle's theorem because it says there exists a c such that the derivative, so I want the derivatives to match. So going back to Zoe's board where she said the derivatives have to match for my new function in the f. So if I have a derivative in there already, I don't have that. So I'm going to replace this with f of b minus f of a over b minus a. I'm going to replace it like that. And then, of course, I'm going to let these be x's. Oh, actually, I'm just going to leave this like this. It's going to be fine. These aren't equal, so they're no longer equal, even though computer science people think they're equal, they're not. Sorry. For computer programming, just let x be very close. You might have problems with that, actually, if you let x be very close, because your denominator will start to freak out. B be very close to A. So now my G that I'm going to settle upon is going to be this one. So I'm going to bring all this junk over to the other side. So this is all scratch work. It's just kind of thinking with my pencil. So does this do what I need it to do to apply Rolle's theorem to this? It's differentiable because f is differentiable. So I got the G is differentiable. So that checkbox of Rolle's theorem, which Kennedy has really nicely on the board up here, there's Rolle's theorem. I need that. Does G of A equal to G of B? Yes. Okay. And G of B equals, if I put B in here, I get f of B minus f of A minus f of B minus f of A. So I get 0 again. Check. Works. So what Rolle's theorem says that's true. and I'm done. Now with 5th grade math, wherever you learn how to just bring something over to the other side, they call it algebra readiness problems. I'm done.
How do you figure that g prime of x with f prime of x minus all that business?
Constant rule, just from,
Oh, that's constant, right?
yeah, these are just, that's just a constant, it's the slope of the secant line. Pretty slick. It's tricky, right? So here's the steps. I set my g of x to be that guy. I show that from Kennedy's board, this is true. It's got g prime exists. Well, g prime is f prime on that, right? F prime is differentiable. It's not f prime on the thing, but it's some combination of f prime and there's a theorem in your Bartle book that says if you have any linear combination of things of f prime, it's also derivative. It's also differentiable. So that's it's continuous because f is continuous. A derivative exists on the open interval, and at the endpoints it's 0. So now when it says there's a c such that g prime is 0. So I find g prime by using the first day of AP Math calculus, run it through. So I know that there's a c that's 0. And then I just add the stuff to the other side and I get the result I want. Slide. All right, mean value theorem is actually, I wanted to use it really badly for show sine theta is less than theta. Let me see if I can do that live. Yeah. But MVT, we know that sine theta minus sine 0 is equal to cosine theta, that's a derivative, cosine c, times theta, or theta belonging to 0 to 1. And then if I just do cosine is bounded by 1, I have sine theta is less or equal to 1 times theta. Remember I needed that the other day for sine x squared? And I was throwing a tantrum at home because I saw mean value theorem showing up in the book a little bit later on and I couldn't use it. Because we were back on the section on continuity and uniform continuity. But look how easy it is. I had to like draw these triangles and sectors on the unit circle and all that stuff to get what I wanted. And I knew I could do this way. It was really, really aggravating. Mean value is really powerful. And at Georgia Tech, the engineers would always write, they see a sine theta in their computation, they just replace it with theta. Because if you have your intervals small enough, then they're going to be almost equal, right? So they just replace it with theta. And I saw somebody do that, and I'm like, why are you doing that? And he's like, I don't know, like that's how the professor does it. They're using mean value theorem. Okay. I got time for one more theorem, I think. We're done here at 10:45. Yeah, one more. The last big gun of calculus. Calculus 1. Differential calculus. somebody asked me, I don't remember who asked me, but they're like, oh, what about the increasing, decreasing stuff? Like, yeah, that's coming up. And we need mean value theorem to prove it. I think, Sam, you asked about that. So I couldn't use the fact something's increasing, decreasing with the derivatives, positive, negative, to prove Rolle's theorem, because I'm using Rolle's theorem to prove mean value theorem, and I'm using mean value theorem to prove that property.
Right.
So that's why I couldn't use it. So here's the theorem, calculus. Stop this.